Good afternoon, everyone, and welcome to another Big Data London webinar. I'm Andy Steed, Content Director of Big Data London, and I'm joined today by regular guest Mike Ferguson and Matt Thompson from Databricks. Hi, guys. How you doing?
Hi.
Hi.
So, like all the time, these sessions are designed to be interactive, so please ask as many questions as you have using the questions function, and I'll endeavour to ask as many as I possibly can at the end of the presentations. A quick note on housekeeping. If you lose the stream at any point, you shouldn't, but if you do, just hit refresh in your browser and you'll jump straight back in. However, without further ado, I'd like to bring on our first presenter. So over to you, Mike.
Thanks, Andy. So good morning, good afternoon, or good evening, everyone, wherever you may be. I'll just get myself onto screen share here. And then hopefully, that's right. So I wanted to talk to you about really trying to bring together two areas, the whole area of AI and data science with the area of BI, which has been in the traditional data warehousing world for some time. So I wanted to start this story off by just looking at the demand for data and analytics right now and the challenges that have been in the way of progress, and how using a cloud-based data lake might help significantly to get round some of the obstacles that are currently in the way of progress. And then also, not only to use a cloud-based data lake to produce trusted data, but also to look at what's happening on the cloud beyond the data lake with the emergence of cloud-based data warehousing and migration of data warehouses to the cloud and all the other analytical workloads going on there, and sort of look at how you could potentially bring these two worlds together and look at the impact of a combination of, say, cloud storage, Spark, and data warehouse, and data lake, and how all of that could potentially come together to integrate these workloads and allow people to leverage what each other has created. So let's get started. So if we look at the data-driven enterprise, obviously at the center of it is data and analytics, and the expectations here at the board level are pretty large. You know, what we've now got, though, as a result of that is enormous amounts of data coming in, both traditional master and transaction data, machine-generated data, human-generated data from social networks and whatnot, external data, all of it pouring into the enterprise that people now want to analyze. And that's opened up a number of different analytical workloads, taking us way beyond your classic data warehouse, whether that's streaming analytics, doing supervised machine learning on top of a lot of structured data, or doing perhaps unsupervised learning such as k-means or natural language processing, which is not unsupervised, but we could be using unsupervised learning to group together information. We could be using natural language processing to pull things out of text, or deep learning to understand images and video and whatnot. And graph analytics, all of that happening now in the world of analytics. And certainly when you look at the investment that's gone on from the Fourth Industrial Revolution survey that was published at Big Data London conference last year in November, this is straight out of the report, which shows, there's been real progress and heavy investment in data science going on through from descriptive all the way up to predictive. It looks like insurance seems to be really, pushing on prescriptive analytics in order to drive significant automation. Oh, sorry, gone back the wrong way. But what are the challenges, given all that investment already? What kind of challenges are currently in the way? Well, we've seen before on previous webinars that I've done, I put up this slide, which is kind of showing that, we've kind of ended up with silos, whether that be a data science silo, data warehousing, graph analytics silos, etc., streaming analytics silos. And we know that there's been a lot of tooling, I guess, that overlaps being used to do similar things across these silos, data integration being an obvious one. Lots of tools and scripts and programming languages being used to integrate data, which doesn't help in terms of trying to share things and share metadata. But also there's an awful lot of staging areas being created for each of these silos that again could involve, in many cases, some of the same data, particularly master data. And the other thing that seems to have happened is that we've ended up with a situation where we sort of still been in silos. You know, we got the traditional business analysts accessing the classic data warehouses and data marts, maybe doing some self-service data prep, pulling out data and merging it with other sources that haven't yet managed to get their way into data warehouses like spreadsheets, and or even connecting to live operational systems in order to mix real-time data with historical data. But nevertheless, you know, it's kind of been a business analyst world, whereas data scientists seem to be off in another world, either on cloud storage or Hadoop, more so cloud storage, I think, these days. You know, with sandboxes, bringing in data into that environment and using it to do feature engineering and build out predictive and prescriptive models. Once they've trained those, obviously, hopefully to then deploy them around the enterprise. But the two worlds haven't really come together that well. I mean, if you take the world of all of the models that are being produced, you know, there's been a lot of questions about, well, you know, I mean, business intelligence users are very keen to make use of any models that are developed by data science within dashboards and within reports, for example. They're very keen potentially to get their hands on some more real-time data in order to reduce the latency and be able to make decisions in a more timely manner because of it. Similarly, also, data science has kind of been interested in a rich set of integrated historical data sitting in data warehouses and kind of saying, well, if we took some of that data plus the raw data coming in from other sources, we could get quite a rich set of features that could really help allow us to develop new models that could be pretty valuable. So there's a kind of demand on both sides to kind of cross over and share things a lot more. But we're trying to do this in a world that's got increasingly complicated. You know, we're now in the business of a kind of distributed, or if you like, operating model. You know, we're now building and operating our businesses on the edge, on multiple clouds, and the data center. And so as a result of that, you know, data is being ingested all over the place. It's being ingested into cloud storage, potentially on one or more clouds. It's being ingested into NoSQL databases on one or more clouds and in the data center. We can even have data stores nowadays at the edge and holding data there in some cases. So because of the fact that we've got data stores in all of those different operating environments, that's making it harder. It's making it harder to find the data that you need, whether you're a business analyst or a data scientist. It's making it harder to even know what data is out there, harder to integrate that data, harder to govern that data, which of course really matters. And the danger with all of this, if we just give everybody self-service data prep, is that you get a Wild West situation, everybody grabbing data from everywhere, and the potential is there to inadvertently create inconsistencies, different naming, etc., which make it real hard to kind of reconcile reports and stuff like that in everyday business. And of course, the danger of everybody doing this inconsistently is that, you know, the term garbage in, garbage out raises its head, let alone other responsibilities like data governance and privacy and protecting data for compliance reasons and whatnot. So if we really look at what we're trying to achieve, we really need a trusted data foundation. And at the same time, also, we want to find a way to bring together these guys, you know, rather than data engineers being in other teams from data scientists who are in different teams from business intelligence users such as business analysts. Is there any way to bring these guys together so that they could really bounce off of each other and get far more productive in a more collaborative way. And certainly the issue around data has taken top priority. I mean, again, if you look back at the survey done over 500 enterprises back in November, you'll see that data quality and data governance and data tools and skills are reigning high even above analytics. It's more important because companies are realizing that if they don't fix the data problem, then the analytics will suffer from it. And so as a result of that, there's a clear push to try and do something about the data problem. But how do you do that across a distributed environment? Where do you do it? I mean, if you've got data scattered across all these environments, it's a bit of a challenge. And so, this is one of the reasons why people are now looking at saying, well, what about a data lake? And, perhaps on the cloud, for example, in order to be able to produce trusted data. So could we bring together data from these different environments and bring it into a kind of central cloud-based data lake? And again, if you look back at the survey, believe it or not, number one priority for 2020 when we ran the survey just at the close of last year was data lakes came out number one, which really showed, given the priority around the data tools and the skills and data quality and governance, plus the area of data lakes, companies really see this as a potential way to solve the problem of data complexity that they currently have. And so bringing data into a data lake on a cloud, potentially having information producer teams to create trusted data within that data lake environment and then open it up to lots of folks that need to use it would be really strong option to kind of publish data as a service that then could mean that everything from data warehouses and data science could start from a common base of trusted data. But it's not just batch anymore. We have to accommodate the world of streaming as well. And so I lost count these days of the number of times companies have said to me, Mike, we really want to become get real-time data warehousing moving, for example. But of course, with streaming analytics, we can ingest that data as it's in flight, analyze it as it's streaming using technologies like Spark or Flink, and then take action on it, and then filter off what's of interest to us for further offline analysis into a data lake environment on the cloud, for example. And so that allows you to act first and then store later for subsequent replay and whatnot that could reveal additional insights when it's integrated with other data. So in order to be able to connect to all of it, we're going to go do this to be able to get this data into a cloud data lake. We already know that our data is scattered across multiple data stores in multiple clouds in a data center and even at the edge. And so we need some way to connect to that. And we need some kind of data fabric software that will be able to do that. Number one, in order to be able to reach that data and bring it in. And we also need to discover what data is there in order to understand what's available to us. And again, data catalogs are a very sort of emerging way to be able to look at this problem, and also to help with once we know what data we have, we can certainly figure out then how to govern it, irrespective of where it may be located. But once you kind of get it into a data lake, it's kind of, well, then what? But what we're seeing at the moment is there's a huge demand to go beyond just getting your data into a data lake. What you can see here again from the survey taken last year is real push for migrating data warehouses to the cloud, machine learning on the cloud. And if you look at the second figure below at the bottom of the slide, you'll see by 2022, as many as 35% of companies said 40 to 60% of their entire analytical workload would be moved to the cloud by then. That's pretty large. And certainly much higher than I expected. But if you combine it with the second answer, you've got over 60%, 63% of companies saying, more than 20%, 20 to 60% of their entire analytical workload will be on the cloud by then, which to me is a clear indicator that analytical workloads are getting higher priority in terms of doing this on the cloud than an operational workload, albeit that we have a number of transaction processing systems already up and running there. So what it tells me is that the cloud isn't just a data lake environment. It's an environment where all kinds of analytical workloads are running right now. And I can do all of this in the cloud, whether it's streaming analytics, whether it's exploratory analytics on unstructured data, whether I'm training machine learning models using supervised learning, doing natural language processing, graph analysis, and traditional data warehousing. But if you look a bit closer at all of this, you begin to realize that there's something that underpins almost all of those analytical environments within a cloud, and that's cloud storage. And because it underpins the others, then it raises a number of questions. And it raises a question, for example, well, could the kind of things you see here, data warehouse, MDM, and these other analytical environments be compute rather than just storage? And what about the storage down here underpinning it all? Of course, streaming is still possible on its way into storing data into a data lake. And so potentially you could therefore bring everything into a cloud-based data lake and then see if we could use a data fabric, create data analytical pipelines, accommodate different role-based usage here, so that potentially we've now got data engineers from IT or citizen engineers in business analysts, and data scientists all potentially looking at data in a cloud data lake in there, but we could potentially bring them all together into a collaborative environment to start working on different elements in order to solve a common problem. But we can go further than that again, I think. We can say, well, let's bring our raw data into our cloud-based data lake. And given that cloud storage underpins these other systems, we could potentially use the data fabric, reach out to those different data stores in different places at the edge in multiple clouds in the data center, bring it into a cloud-based data lake and ingest it, and then work on that data to create trusted data, which is then sitting underneath all of these analytical environments. And so now what we've got is the potential to kind of like build once, share everywhere. And so you start to begin to realize, oh, hold on a second, now I can get consistency potentially across multiple analytical systems rather than just give everybody self-service tools and go, knock yourself out. So then again, we could also even put other technologies on top of that, like data virtualization, create a logical data warehouse, and then we can have different virtual views of all of this data to meet different business demands around your enterprise. But it's more than that in a sense, because when you start to look at some of the components that are sitting there on a cloud, you begin to realize that, well, maybe we could do more than that, and particularly around the world of data warehousing and cloud storage. And is there anything that could be done there to deepen the integration? So let's look at that in a little bit more detail. Of course, what we could do is something like this. We could ingest streaming data into a data lake, and land it in the data lake, and you could have traditional data warehousing systems running in the cloud with external tables pointing at data within the data lake. That's pretty common practice these days. The interesting thing about that is then that data scientists could access data in the data lake, but they could also then access the data warehouse through, say, Spark SQL or data frames. Whereas traditional BI users just carry on using their BI tools. And so we start to bring these two worlds together a little bit. But we could potentially go even further than that. And for me, this is where it gets really interesting, because we could then say, well, if Spark was brought closer to the data warehouse, and we are able to connect and run Spark applications on the data warehouse, that's one aspect. We could potentially even create models and deploy them in data warehouses. We can bring streaming data in, as I mentioned, into the data lake in the cloud and potentially make it available to give us a real-time element. But we could potentially go further, because if you actually look across this, you realize that Spark is kind of, well, it's kind of everywhere, I mean, you can run it to do streaming analytics. I can run Spark on Hadoop. I can run Spark on Kubernetes without Hadoop. I can run it as a service. I can run Spark to access graph databases, or I've even got GraphX as part of the Spark framework, as you can see top left. I can run Spark, to access the data warehouse and potentially any other relational data. It could be in master data, for example. But it goes even further than that, because Spark is effectively everywhere. Then, and we're also now seeing just lots of data prep and traditional ETL vendors and data fabric vendors now all running that software, those jobs on top of Spark, in order to give us that capability to get scalable ELT processing. But in addition, we also know that Spark has now got koalas, rather than pandas, and if you're a Python programmer, you can just leverage koala, data frames as if they were just standard panda data frames, and just go at your data as well. So you begin to realize, I'm sitting here with a framework that can support streaming, machine learning, graph analytics, data frames from Python perspective, and SQL. And so then you begin to say, well, could further integration start to happen in that case? So by that I mean, well, what about, let's look at what we could potentially do here, given that Spark has all of that capabilities. Well, if we've got a data lake with cloud storage and Spark can connect directly to it potentially, then do I need the Hadoop side of it? What about graph? Well, I can still do graph. Well, what about, since cloud storage is underpinning the data warehouse and also underpinning MDM, potentially could they not go down into the data lake and put Spark over the top and bring both worlds of AI and BI together? And then what you get is data scientists and business intelligence users potentially using the same data. It certainly makes you think as an architect as to what's potentially possible here to simplify data architectures. But, this isn't new necessarily. It's, several vendors have been, already able to replace Spark SQL with their own SQL engines to run against data on cloud storage or indeed within a data warehouse. Several vendors are capable of doing that, and I can certainly talk offline about that after the presentation. But this kind of capability works whether or not the data warehouse data is actually the same as is in the cloud storage. Doesn't necessarily need to be in cloud storage for that capability to work. But I guess the attraction of bringing data science and BI together is not just to develop, that is not just to develop models and develop reports and dashboards, but the deeper integration is, well, if I do develop a model, how can I deploy it so that the business analyst using a BI tool can use it in order to take advantage of the new capabilities that a data scientist has potentially created. So if I look at this a little bit more closely, then that's something that we could clearly do. But big questions would be asked, because if this isn't a database, it's just object storage, then you need to be able to support updates to this environment at a fairly rapid rate, and preferably in a format that is instantly viewable through SQL, such as self-describing Parquet files, which are columnar files. And so in that sense, being able to land the data already in high speed, high velocity data streaming in already in Parquet would really matter. But I may need to support ACID being the properties of a transaction if I'm doing that in the same application as trying to read the data. Another thing will be I/O performance, because we need to make sure that object storage is going to be able to deliver the kind of performance capabilities that we've had, let's call it, within traditional data warehousing in the past. There's other questions like, is Spark SQL on Parquet would have to be as good or better than existing data warehouse databases in order to choose to go down this route. And probably one of the more challenging questions is, well, for all of those people who built data warehouses with Kimball design techniques, which is a pretty worldwide standard, or in Europe in particular, where Data Vault is definitely becoming a standard in some parts of Europe to design data warehouses, then what? How do you do that on cloud storage with Parquet files in order to support a data warehousing environment, whilst at the same time opening the door to data science? Or even better, could you isolate the workloads in different Spark clusters? Because after all, that's just compute. We can run Spark on Kubernetes, for example, and therefore, well, why can't I have multiple Spark clusters for different kinds of workloads? I can run my ELT processing on one Spark cluster, keeping that separate from data science on another, keeping that separate from business intelligence users, using Spark SQL to get at data on another, and even running streaming analytics on another. So you could potentially isolate those workloads, stop them bumping into each other, if you like, and take advantage of the separation. But again, you need to be able to support some of the core requirements of data warehousing if you're going to ditch a data warehouse and just point it at cloud storage, if you see what I mean. and we've got to be able to handle that. And certainly, our sponsor today, Databricks, is certainly challenging this space and looking at this with their platform. And I know Matt's going to walk you through some of this after my presentation. But clearly, in this kind of environment, your optimizer and partitioning the data across the compute clusters is going to be really important to performance. But the question is this a new way of building a data warehouse? Or is Databricks going to challenge the database market and go after Oracle, go after Microsoft, go after IBM and Snowflake and everybody else? Be interesting to see how that materializes. But it's certainly food for thought, no question about that. The key thing, however, is that we're going to bring this together, really bring it together, AI and BI workloads. Then the output of a data scientist has to be consumable as input, if you like, by a business analyst. And the output being the model that's deployed. And we want the model to be deployed so that it can run close to the data in this environment. And then hopefully be able to invoke that in an analytical pipeline, either through a notebook or from a BI tool as a service or as a SQL function, in order for it to run, closer to the data, rather than trying to suck the data out into some other environment in order to do this. But with Spark, again, I could build my model or my pipeline effectively, and then invoke that and have it run close to the data in order to give me, if you like, a predictive element or even a prescriptive element like recommendations or alerts into my BI environment, and bring these two worlds together on top of common data. So I hope that gives you sort of some idea of what you could potentially do here. There's some big questions, if you like, to be asked, however, but nevertheless, some of the things to think about is, there's been a huge investment in data science by stakeholders, and board level investment is very significant nowadays. It's very high priority. But a lot of the time, what's happened is that money has been sort of split up to different business units, and they've all been handed their own budgets and gone off and bought their own tools. And for me, that's resulted in a lot of silos all over the place. And we're not getting as much value out of it as we could, because we're not sharing anything across the silos. And as a result, also the complexity around data, more data coming in, plus data being stored at the edge in multiple clouds in the data center, has really seen an issue around data. And well, what data do you trust? Where is it? How do I find this stuff? And how do you make sure it's top quality? And so there's really been given a high priority around the whole area of data governance and data quality to try and get a trusted base from which to move forward from. And many companies are looking at cloud data lakes to solve this problem, to bring the data together into a centralized environment, and then use role-based data fabric and catalogs and collaborative development to bring together the right folks to be able to produce, reusable, trusted assets that allow us to really take leaps forward. But in the cloud environment, it's not just the data lake. We've seen massive move of other analytical workloads, including data warehouses in the cloud, either through new data warehouses being built there or migration of existing data warehouses over there. And given that that's happening, people are now beginning to say, well, could we deepen the integration between data warehouses and data lakes, since cloud storage is underpinning the data warehouse anyway. And Spark on top of a cloud storage environment certainly would potentially make that possible in hopefully the ways that I've kind of shown you there. But it opens up, I guess, competing options, which is, do you run a Spark on a data warehouse in the cloud, or do you run Spark SQL on Parquet data in cloud storage as your database? It's an interesting debate. We'll see how it pans out, but certainly if we can produce those models in data science and then deploy them to be consumed in BI environments, and we can also stream data straight into data lake environments and make it available to both data science and BI, as long as the data is trusted and not just raw, so that we can build once and reuse everywhere, we stand a great chance of really getting shared analytical workloads in a cloud environment. So I hope that's given you some indication of what might be possible. And I guess with that, I'm going to hand back over to Andy.
Hi again, Mike. Yeah, so just while you take the slides off, I was just going to mention the fact that we've had a couple of requests for the slides. Anyone who joined this session late, the session becomes available on demand pretty much as soon as this session finishes. So if you want to go over the slides, if you'd like, there's a couple of elements you'd like to go over again, you'll be able to log back in there. If you missed the start, again, you can just watch it from the beginning. So that's absolutely fine. Before I pass over to Matt, I'd just like to make you aware of some links we've got. If you look in the bottom left-hand corner of your screen, there's some attachments. There's some Databricks attachments that are going to support Matt's presentation coming up. But there's also some links to our upcoming webinars. We've actually, for webinar fans, we've got another webinar today, believe it or not. So there's a webinar starting at 5 o'clock for anybody who'd like to see that panel, the details of the panel on the attachment. However, without further ado, I'd like to pass on to Matt. So take it away, Matt.
Awesome. Thanks a lot. Thanks, Andy. And thanks a lot, Mike, for a really interesting presentation as well. So hi everyone. My name's Matt Thompson. And I work at Databricks. I work in the customer success team at Databricks. I actually lead the machine learning practice for resident solutions architects at Databricks, which really means I help customers to build and deploy their sort of Spark and machine learning applications on top of Databricks. And what I wanted to do today was just talk to you a little bit about some of the challenges that I've seen, or that we've seen in working with our customers, implementing some of the the sort of data science and BI workloads that Mike was just kind of talking about. So I guess before I just to start off, in case anyone's sort of not familiar with who Databricks are, I just wanted to quickly introduce us. So Databricks is a software company fundamentally, and we provide a cloud native managed service to provide a unified data platform for data teams. So it's a unified kind of data analytics platform that really allows sort of data engineering, data scientists, and analysts to really come together to build their big data and machine learning applications. And I think the kind of key is that, you know, it's bringing all of those different you know, Mike was sort of describing how some of these different areas have previously been siloed. Well, with Databricks, you can sort of really bring all of those different aspects together into a single unified data analytics platform. So we're a global company. We've got over 5,000 customers. We work with 450 partners. Probably best known for being or for being founded by the original creators of Apache Spark, which Mike highlighted quite a lot there as the sort of de facto standard for processing and analyzing and doing analytics on data at scale. But we've sort of grown a lot since then as well. And you know, we're actually also the original creators of a number of other open source projects such as Delta Lake and MLflow, both of which I'm going to sort of come on to talk a bit about as well. And also recently working with Red Ash to really bring together the sort of that BI and SQL piece of the puzzle that Mike was referring to. So I guess I just wanted to start off by just quickly covering some of the challenges that that customers face. So you know, I think building a data lake and applying machine learning and analytics on top of that. I think there's been a lot of, I don't think anyone's really in doubt now that machine learning and data lakes and analytics have a huge amount of value to add to businesses. I think what we found is critical is actually combining the analytical space with the machine learning space, bringing those processes together and breaking down that silo. But it's a very challenging kind of problem to solve, and the reality is, at least that I've seen, is that most organizations actually really struggle to unlock that value due to some of those silos, and those silos are not just in terms of the people, but also in terms of the data and the technology. And that's pretty understandable, right? Because you've got this sort of ecosystem where you have data coming in all sorts of different formats and different paradigms, be it streaming, be it data lake, be it sort of NoSQL. You've then got all of these different sort of array of tools and processes for how to actually generate that value, build and deploy those applications on top of that data lake. And it kind of boils down to 4 kind of key challenges, and I just want to walking through these different challenges. And so the first is that really data is messy, siloed, and slow, right? And so you have all of these, you've got streams, you've got data warehouses, you've got data lakes. They're all, bringing these things together can be a real challenge to actually get value out of that data. And I think, and that's where Delta Lake comes in. So Delta Lake is an open format operated by the Linux Foundation, and it provides, I guess the way I like to think about it is it provides structure on top of your data lake storage, first and foremost, right? So it takes all that raw messy data, provides that structure, but it does that in a way that not only provides things like ACID transactionality that allows streaming and batch data as well to sort of really come together. You can actually build a single Delta Lake table that you're sort of streaming data in and you're updating via batch, and it sort of works seamlessly kind of together. But it does that by introducing a series of features that allows much faster kind of reading and processing of that data as well. And with the Delta engine sort of underpinning how you interact with that Delta Lake, that really allows that sort of combination of BI reporting and machine learning to really come together. The second problem, of course, is all around machine learning. I'm a machine learning specialist, so this is sort of my bread and butter. And I think the core problem here is that machine learning is quite a hard problem to solve, but actually the real challenge is actually productionizing that those machine learning solutions. And with Delta Lake sort of really getting your data structured, getting it ready for analytics, that means building models on top of that becomes a lot easier. And we at Databricks have got a few key aspects that sort of really help make that process easier again. And the first is our Databricks runtime for machine learning that brings together all of the different technologies that you might want to use for machine learning to build, so that you can build your models in whatever sort of technology you like. But then critically is the piece running along the bottom, which is MLflow, which really standardizes the process of going from experiment through staging and testing, and all the way through to production, and doing that in a sort of common interface that means regardless of the technologies you're using, you can build these models in the right way and apply, the sort of ML governance, or the governance around the machine learning models, that is sort of really critical. The third part is then, traditionally BI is actually limited to a fraction of your data. You can only read a small portion of that data into those systems. Well, with Delta Lake and especially with the Delta engine, you can suddenly start to get that high performance, that high query performance in an integrated BI environment. Regardless of the different BI tools that you might want to use there. And then finally, doing that in a secure manner. So making sure that your data and your users are using that data in a secure manner, and that has been traditionally a real big challenge that the companies have faced. We solve that problem through our enterprise cloud services. So using things like Active Directory and Okta to manage, as your identity provider, to manage users accessing the platform and accessing the data. And then all of your data, actually, when you use Databricks, still sits within your cloud account, be that on Azure or AWS. And the sort of lines at the bottom are the different kind of compliance certifications that we have as well. So kind of bringing all that together is the sort of Databricks unified data analytics platform. And this is what we call our kind of layer cake slide. You saw a sort of a version of this in Mike's presentation as well. But really, at the bottom is a data lake for all of your data on cloud storage in either AWS or Azure. Combining that, bringing together that structured, that semi-structured, and that unstructured data into a single place. You then have Delta Lake, which provides that sort of structured transactional layer, really gets your data sort of ready for analytics and machine learning. You've then got that sort of high performance query engine, the Delta engine on top of that, to enable querying that data at scale in a very performant way. And then finally, the point is we have a single platform for each use case. So be that BI reports and dashboards through something like Redash, be it the data science workspace to build your models, and ML Flow to manage that machine learning lifecycle. And really, that's sort of that's the sort of core part of the platform. We've been working with I think I said at the beginning, something like over 5,000 customers. This is obviously just a snapshot of some of those customers. I think the interesting thing for me is that is the spread of industries across which we can work, and this same kind of unified platform really works for these different companies, for these across these different industries. And what I thought I'd do is just select a couple of these examples to kind of really go into a little bit more detail around. And the first is on the sort of retail CPG and e-commerce side, and it's a customer that I've actually worked with personally, called Waycamp. And Waycamp, in case you're not familiar with them, are a leading e-commerce company based in the Netherlands, and they really wanted to create a sort of personalized shopping experience for their customers. So they wanted to serve real-time recommendations to their customers, and they needed that. I guess the sort of why did they choose Databricks to kind of solve this problem? Well, they needed that unified platform for data science and data engineering and analysts to really come together, to build those, to determine firstly, what models are useful, what kind of recommendation type models are going to be useful, before then building the recommendation model itself, before then deploying it to that page to provide those recommendations, but also to analyze the impact that those models are having, so that you can tune and refine and monitor those models. And that's again where sort of MLflow comes in, enabling that really easy experimentation and model tracking, and rapid iteration across those machine learning models. And just as a final point in terms of the impact, so they build sort of hundreds of models per day for these recommendations, resulting in sort of 70% reduction in their operational costs, and I think doubling their revenue due to that increased customer engagement. So it just shows you that the impact, firstly, the potential impact that data and AI applications can have, and how you can use Databricks as a single unified analytics platform to really build out those, to achieve that value. My sort of final slide, or my final example, is some work we did with Shell. Now, Shell had a real problem. One of the challenges we had with working with Shell was to manage their supply chain inventory. So they have something like, in order to sort of maintain production of their oil refineries, they have something like 3,000 different types of spare parts that they might want to leverage. And obviously, if they run out of those spare parts at a particular warehouse or part of the supply chain, that can be very costly. But equally, if they sort of overstock, that can be similarly challenging. And they wanted to build a model to predict the sort of optimal stock levels that they needed in order to maintain production. And again, it's the sort of common theme of why Databricks. Well, it was really, we needed the data scientists to build the models, but we needed the data engineers to process the data, and we needed the analysts to provide that sort of that business and domain knowledge to direct those models and those data engineering efforts to some degree. So and by coming together in a single unified platform, that enabled them to improve those supply chain operations, and in fact build those data pipelines to predict when they needed to purchase those parts and how long to keep them and where to store them as well, right, across the globe. And again, just quickly the impact, that meant we were able to provide those recommendations something like 32 times faster than they were able to do individually. The key part there actually was using Spark to distribute the modeling, so that you could build like lots of different models at the same time in order to provide those recommendations. It actually resulted in sort of millions of dollars worth of cost savings across those 50 different locations. So hopefully that gives you a bit of an idea of the sort of challenges that Databricks that we've seen and that I've seen as sort of working with customers at Databricks, how the Databricks unified data analytics platform really looks to solve those problems, and then a couple of examples to just illustrate how that can operate in practice. So I think that's all the slides I had. So keen to take any questions that there might be, and I guess I'll hand back to Andy.
Thanks, Matt. Yeah, I've got a few questions. We'll definitely do some questions before we have to go. So I was going to start with you, Mike, if that's okay. Yeah, you're on mute, so yeah, make sure you turn it off before you answer. How important are the data catalogs becoming in unifying data and analytic workloads? Yeah, how would you?
I think they are, because I mean, obviously, people have to know where the data they need is, number one. But I also think data catalogs are becoming more than data catalog. They're becoming catalogs that can tell you what data exists, but also what other artifacts exist. So, you know, if there is a machine learning model that's been developed by a data scientist, you could publish it in a catalog and then allow others to potentially leverage that as a service, and make them aware, you know, so that you bring these workloads together. So I think it's needed for two reasons. It's needed by data science to know what data exists in a data lake environment, or indeed outside of the data lake environment that you want to ingest into it from that distributed computing environment that I talked about.
Okay.
And it's needed by you know, business intelligence users also, to know about what data is available that they can potentially use. But in addition, I mean, people talk to me about putting BI tools directly on a data lake. Well, I mean, if you put it directly on raw data, then you're forcing complexity to some extent onto a user to try and figure out what's in there. But I think if it's on trusted data, there's no question, and a catalog's got the availability of what trusted data is available in a data lake environment. No question that business intelligence could potentially, users could potentially leverage it from BI tools, even if that data hadn't yet made it into a data warehouse environment. So I think it's got a big role to play.
Yeah, excellent. Okay, I'm going to ask a question to Matt, and I'm going to ask a similar question to we asked in the last Databricks webinar, which some of you may have been on with Punch. What kind of team structure are people having when they're doing work with Databricks? Does it affect them from a team perspective, more from a kind of a, you know, softer skill personnel kind of point of view?
So really, it's a really interesting question, actually, and I think I see. You know, I work with customers sort of ranging from sort of full-on big enterprise customers down to sort of smaller companies, and it's hugely variable. So I think it works best when you can bring those teams together to, you know, to build out those applications as a single on that single platform. You've got a unified platform, so it makes sense for those teams to just kind of come together in a single place to build those applications. I think that's where I've seen it work best.
Perfect. And I'm going to stay with you for a second, because there's somebody actually asking for some more detailed Databricks information, and we were talking just before the call about the Spark Summit that happened. So do you want to give a little bit of details about where people can find a little bit more online, perhaps?
Yeah, for sure. Thanks. So yeah, for anyone who's not aware, so we at Databricks ran a Spark Plus AI Summit 2 weeks ago. It was a completely virtual summit. All of the videos from that summit are available on demand. So I think you should just be able to search for Spark and AI Summit, and it sort of should pop up. I'm happy to share the link afterwards. But there's some really great content in there that we had. I think it was, you know, a huge number of people attended the session. I think something like over 30,000. And there's a lot of really good content on there around how not just how Databricks works and how Delta and how Delta Lake can really help that, but also some really good customer use cases of how customers have used Databricks to solve these traditional sort of data and AI challenges.
Perfect. I'm going to come back to you now, Mike. If cloud storage is underpinning data warehouse in the cloud, is a schema no longer necessary? Is a schema no longer necessary if you want to share the same data across a data warehouse and data science?
Absolutely, a schema is necessary. I mean, you can't just ditch, you can't throw data in a data lake and just say, here's your data warehouse for schema and read. I mean, for me, that's just complexity. You know, we need to know the structure of the data when it comes to it. So I don't see the practices that have been used in data warehousing being thrown away just because the data that's being stored for a data warehouse sits in cloud storage in an underlying data lake. So for me, absolutely, you still need a schema. And I guess that also means, therefore, that if you're preparing data, to sit in a cloud storage, as opposed to a separate storage for your data warehouse, then very obviously, you need to make sure that the files that you create fit the schema that you want to use within the data warehouse environment. So from my point of view, absolutely, you still need a schema.
Perfect. And we've actually got quite a number of questions now. A lot of them are quite specific. We will make sure that we get back to you on those afterwards. There's one here which I'm going to slightly reword. So it's how does Databricks stand out from competitors? And it's mentioned a few of the big competitors that you imagine. The question, how it was asked in the previous webinar, Matt, was to Punch, who are one of your customers. If Databricks was taken away from them, if all the work they've done taken away, what would they miss most? So, what do you think your customers and the people you work with would miss the most if suddenly Databricks was taken away from them tomorrow?
It's a really, really interesting question. And I'm sorry worried that I'm going to sound like a bit like a broken record, but I think it's that single unified environment that every their whole teams can use, and especially, I guess maybe let me put it from as I said at the start, my specialist is on machine learning, and I think maybe let me phrase it in that way, and the challenge of building and deploying and productionizing machine learning models is such a big challenge, and sort of Databricks it provides that solution, and I think suddenly you'd find that you've got lots of different teams working it back to that siloed approach, really struggling to get those machine learning models sort of what I call out of the lab, that sort of beyond just something that you do on your laptop and actually getting that business value or getting that value to the business. Perfect.
So any Databricks customers on here, don't worry, we're not going to take it away. Just in theory, that's what people would miss. Punch said speed out of interest. It was speed was the big thing for them. Yes, so we've got lots of questions and lots of very good questions, and thanks so much for sending them in. I think we're running slightly over time, so we're going to answer these offline. We'll send you answers after the webinar's finished. Like we mentioned, it'll all be on demand. Please do come in again and go in and over any bits of the presentation you'd like to see. And yes, like we say, our webinars calendar is on our attachments. Do come along to the next few that we've got coming along. But for now, it's goodbye from us. So goodbye, and thanks very much to our presenters who did a wonderful job today. So thanks, Matt. Thanks, Mike.
Thank you.
Thanks a lot. Cheers.
Thanks a lot.
Thank
Bye.
you.
Bye-bye.